Good morning to everyone. Today we are going to learn what is singularity or singular point, type of singularity and some related problems. So first we will move on to the what is singularity and learn the definition of singularity. So singular point or singularity of the function f of z is singular point or singularity of at a particular point z equal to z naught at which a function f of z fails to be analytic is called a singular point or singularity of f of z. That means the function is said to be analytic at a particular point. The function is not satisfy the analytic condition. So what is we very well known about the analytic. So we have the two conditions. If you have satisfy the two conditions, the condition is said to be analytic. The function is said to be analytic. Condition number 1 is nothing but should be satisfy the CR equation, and condition number 2 is nothing but the partial derivatives should be the continuous. Okay. So now we look at the example. So example number 1. What is the example number 1? Consider f of z equal to 1 divided by z minus 3. So here is a function value is the 1 divided by z minus 3. F of z is nothing but a function equal to 1 divided by z minus 3. So how can you check the function is analytic or not analytic at a particular point? First we look at your denominator. What is your denominator? Z minus 3. So if you substitute the z value equal to 3, your denominator will become 1 divided by 3 minus 3. So 3 minus 3 is nothing but 0. So your function become 1 divided by 0. So 1 divided by 0 is nothing but the value is infinity. That means f of z become the infinity. That means the function is not analytic at a particular point z equal to 3. So that means at the point if you substitute the z value equal to 3 in the denominator, you will get the f of z value. F of z is not analytic. That means z equal to 3 is a singular point of f of z. So this is a process to find in the singular point. So next definition is a isolated singularity. Isolated singularity is nothing but that should be a singularity. Isolated is nothing but the condition is satisfied exactly only one point, not the other point. That means the function is satisfy the singularity condition exactly one point, not the other point. So if you satisfy the exactly one point, that point is said to be isolated singularity. So now we look at the example. So example is consider f of z equal to 1 divided by z. First you find the singularity. We very known about the how can you find the singularity. How can you check? Move on to your denominator. What is your denominator? Denominator is the z. If you substitute the z value equal to 0, your denominator will become the infinity. So for substitute z value equal to 0, 1 divided by 0. 1 divided by 0 is nothing but infinity. So that means and the function f of z is not analytic at the point z equal to 0. So z equal to 0 is a singular point. So singularity or singular point, both are the same. So z equal to 0 is a singularity. So no other point is, if you substitute any one of the point in the denominator, that will not get a not analytic. Okay. So exactly only one point, only one possibility is z equal to 0. If you substitute z value equal to 0 in the denominator, the function is not analytic. That means z equal to only one point satisfy the singularity condition. So that means z equal to 0 is an isolated singularity. Okay, so next we move on to the types of the singularity. So here you have the three types of singularity. One is a remote singularity, another one is a pole, another one is an essential singularity. So to verify these three singularity, so you have the two methods. One is a principal part method, another one is a limit method. First we will study what is principal part. So definition of principal part is the series consisting of a negative power of z minus c. That means function, so if you have a function, you convert the function into the series format. If you have the series, so if you have a series in the negative power of z minus a means that is a principal part. If in case in your series doesn't has the negative power of z minus a, the series does not has the principal part. Okay, so principal part is very simple. Principal part is nothing but a negative powers of z minus c. Okay. So next one is the node number 1, node number 2. This is nothing but method number 1, method number 2 to finding the type of singularity. So here is already we learned here is three type of the singularity: removable, pole, and essential. So node number 1 is nothing but method number 1, method number 2. So method number 1 is using the principal part finding the type of singularity. Method number 2 is the using the limit point to finding the type of singularity. What is the method number 1? First one is that there is no principal part, means that singularity is called a removable singularity. So what is principal part? There is no negative power. If you don't have a negative power, means the singularity is called a removable singularity. So second one is that if you have a finite number of principal part, means that singularity is called a pole. Third one is that if you have an infinite number of principal part, means that singularity is called a essential singularity. So this is the method number 1. So method number 2. So limit method. If you substitute the limit value, so limit z tends to a is nothing but a singularity. Okay, singularity point. If you substitute a singularity point in your given f of z, if you have a point value is finite. If you have a finite value, that singularity is called a removable singularity. If you substitute the singularity point and to the function, if you have a value is infinity, means that singularity is called a pole. So third one is if you substitute the limit value, you don't have any one, the limit does not exist, means the singularity is called the essential singularity. So these two methods we using these two methods to finding the type of singularity. So now we look at some problems. How can you finding the removable singularity, pole and essential singularity? So problem number 1, find the nature of f of z equal to sin z divided by z. So nature of f of z is nothing but you should tell whether that is a removable singularity, pole or essential singularity. Okay. So first method number 1. Method number 1 we using the limit value. So method number 2 is we using the principal part method. What is your method number 1? Limit substituting method. So first one you write taking the given f of z equal to sin z divided by z. First we find the singularity. What is the singularity? What is the denominator here? Z. So substitute the z value equal to 0. Your function will become the infinity. If you substitute z value equal to 0, sin z divided by 0. That means if you have a denominator value is 0, means the value become infinity. Therefore f of z equal to infinity. So that means z equal to 0 is the isolated singularity. Only one possible singularity values. So now substitute the limit value. Limit z tends to a f of z. So here is a is nothing but your 0 singularity value. So substitute limit z tends to 0. Sin z divided by 0. Substitute the z value equal to 0. Substitute the z value equal to 0. You get the sin 0 divided by 0. Sin 0 value is nothing but 0. So 0 by 0. 0 by 0 is nothing but undetermined form. So in this format, we using the L'Hospital rule. So what is the L'Hospital rule? In your given f of z, you can differentiate numerator as individual and denominator as individual. So limit. So using the L'Hospital rule, in your numerator is sin z. What is the differentiation of sin z? Sin z is nothing but cos z. So denominator value is z. What is the differentiation of z? Z here is z is the variable. What is the differentiation of z? Z is nothing. Differentiation of z is nothing but 1. Now you substitute the limit value. Z tends to 0 because your isolated value is the isolated singularity value is 0. So limits, if you substitute z tends to 0, you get the cos 0 divided by 1. Cos 0 value is nothing but 1. So 1 divided by 1 is nothing but 1. 1 is nothing but, so now we check whether this 1 is nothing but finite or infinity or does not exist. So we very known about that 1 is nothing but finite number. So finite means finite means using the method number 1. If you have a substitute the limit value that you have a finite means that function is called the removable singularity. So here is you have the finite values. That means the limit exists and finite. So z equal to 0 is a removable singularity. So this is the method number 1. So next one, same question. We will use the method number 2. How can you find the singularity loss, the nature of singularity? So what is the method number 2? Principal part method. So principal part method means you convert into the series format. So first you write the given term f of z equal to sin z divided by z equal to, so sin z divided by z can be written as 1 by z into sin z. 1 by z is nothing but, so first you have 1 by z into sin z. Write the 1 by z as it is sin z. So what is the series expansion of sin z? This is the series expansion of sin z. So now next step is multiply the 1 by z inside the bracket, you get the series expansion like this. And simplify the term, since tan and the denominator z and numerator z. Similarly, all this, you get the final answer is like this. What is for principal part? Principal part is nothing but negative power of z. So now you check here, z is in your numerator. So z square, z power 4, z power 6. Now look at the powers. Power is nothing but plus 2, plus 4 and plus 6. There is no negative powers. So in your f of z, there is no negative power in z. That means in your principal, using your principal part method, so here is there is no negative power. That means that singularity is called a removable singularity. So this is a method to finding the type of singularity using the method number 1,